Alrighty. So today is about TCP IP, which is a little bit, it's not misleading, but we're definitely opening up a can of worms here, but it's a good can of worms. Out of curiosity, I always like to ask you guys if you are using this, how you're using it, if you've heard about it before. So whether you want to unmute your mic or type in the chat, I'm curious to see if you guys have heard of TCP/IP before, or heard of maybe even MIDI and things like that, or how you may be implementing those. Open up the chat here. Yes and yes. Has heard of it and is using it. I'm aware of it, but I'm interested to learn more. Okay, good stuff, good stuff. For control. That's right, Johnny. That's right, Johnny. For control. Yeah, essentially, the way that we're implementing TCP/IP is for control purposes. And we'll kind of unlayer that as we get through here. But let me tell you first why you should care. Like why, what, I don't even know what it is, but more importantly, why, like, get me hooked on first. Why should I even care? So a lot of our gear actually uses TCP/IP to send control data to one another. And things like the D-Live surface and the mix rack, that is a complete TCP/IP connection. You can kind of think of the surface as being like a really advanced super ultra mouse, but it's just sending control data from the surface to the mix rack, which is why you're able to have a mix rack run entirely on its own. Like that is the whole console, really. You can not use the surface at all and use the mix rack and have a full D-Live system for that exact purposes. Our mobile apps use TCP/IP, custom control, the IP controllers, all of our consoles where they're using TCP/IP in some way or another. But TCP/IP stands for Transmission Control Protocol over IP, and IP is Internet Protocol. Oh, looks like checking the chat. Hi, William, but I do have a note. Okay, good. Well, I was wondering where you were, but I'm glad to see you're here. So Transmission Control Protocol over IP. This kind of defines how applications create communication channels. You can sort of think of this as creating like a very specific private network, very tiny, like instantaneous. Like it's not like the World Wide Web or anything like that. It's just a little specific connection we can make with applications or our control surfaces in our mix racks, for instance. Oh, good. We have a retired IBM mainframe software engineer. So, no stress, no worries. Well, Dale, please feel free to add any commentary or anything you think anybody would find helpful. I am a simple audio woman from the Great Plains of Kansas. So this is going to be through that lens. That's right. I also forgot William. There's a lot of IBM mainframe software engineers in this call today. More than one. That's great. It's good to have you guys. Okay, so again, we're kind of defining how applications create communication channels. So TCP itself, it's just a protocol, so it's not proprietary. Now, the actual commands and the programming that our stuff uses is proprietary. We're not using OSC or anything like that. It's kind of our special thing that we made specifically for our stuff, just like we built an FPGA for us. Same kind of deal. So let's click through here. What does this kind of turn into? What does me using TCP or having this control, or what does this actually mean? So when you kind of boil it down, it means that we can write commands using what's called hexadecimal. And basically, to really be very, very reductive, we can make hardware do what we want it to, by either using other pieces of hardware or using a piece of software or lots of different things. So you will need either a piece of technology that accepts MIDI, sometimes people call it MIDI, or TCP/IP commands. You'll need a CAT cable, so like an Ethernet cable to connect stuff together. And you'll either need an AHM, an SQ, an Avantis, or a DLive. All of that accepts TCP IP and MIDI stuff. So don't need all of them, just kind of need one of these little bits and bobs. Even if you just only have one of them, like the demonstrations I'll give you guys today, I'll actually be using like an AHM to trigger something on the AHM, or I'll program something on the Avantis for you guys to trigger something happening on that Avantis, but it's easy for me to send it and do the command to a different piece of hardware. So okie dokie. Let's get through all these good pieces of information that are just, if you ever have a weird like fact game, you guys can pull these out, a party trick, if you will. If the conversation gets boring, you can talk about how the IP6 and the IP8 are only running at about half of a megabit per second per connection. In other words, it's very small amounts of data. That's what's kind of great about TCP IP and using hexadecimal and all this stuff, is that the actual bandwidth needed to send the commands place is actually very, very small, which means we can have lots of different connections going at one time. So, all right. So the IP6 and the IP8, just for a fun fact, have a very low connection. The DLive surface and the mix rack can each support up to 40 TCP connections. So in a very chaotic world that I would not recommend, you could connect 40 surfaces to the mix rack. I don't even think that's possible, but just as an example. Or you could have, probably more accurately, like the director is a TCP IP connection. That's one of them. The surface is a connection. Sometimes people put like 2 surfaces on one mix rack. That's a TCP IP connection. The mobile apps, like I had mentioned earlier, those are TCP connections. The AHM, which I've talked about so many times, is our matrix processor, and it can actually hold up to 100 TCP IP connections. It can have that many connections going simultaneously, because it's really meant to hold all those different kinds of control applications for it. So like if you were installing the AHM into like a big school campus, you're going to need lots of different kinds of control, lots of different access kind of points for control. And so 100 TCP connections is a lot. You can actually have 64 of the IP1s and 16 each of the IP6 and the IP8. The IP6 is in the bottom right of the slide. 16 each of those, and that still leaves 4 more connections. So the system manager is a TCP connection, just like a DLive director or Avantis director is a TCP connection. Also, our GPIO is a TCP connection. If you guys didn't know, that's what this middle left picture is our networkable GPIO, which is really could be its own mini masterclass. But essentially, I can make things happen outside of the electronics world by programming things with GPIOs. I can have things happen because I push a button, or I can push a button and have something else happen inside of the HM. The GPIO connection is also a TCP IP. And custom control, as I had mentioned, is also every instance of that is TCP. I hope you guys are like really liking hearing TCP IP, because it's going to be coming out of my mouth a lot. Okay, so the other really kind of big important point that I want to make is that sometimes these phrases are used a little bit interchangeably. I'm a little bit guilty of this as well. So MIDI, TCP, serial, like a lot of words coming out here. So TCP is the actual connection itself. That's just the protocol we're using to make the connection between devices. The MIDI is kind of like the musical interpretation of these commands. If you dig into MIDI some, they're normally like note on or note off. And you'll even see that in some of our documentation that I will pull up and show you guys here in a minute. But it's like the interpretation of the commands. And those commands are actually written in hexadecimal. When that's what we type in, that's what we're going to be typing in System Manager. And I'll show you guys on Avantis, like that's what we're typing in as hexadecimal. And then the serial strings are just like the commands written out like in one piece. So it'll be like a series of hexadecimal notes. And so if somebody says, oh yeah, send me this MIDI command to do this, or hey, can you send me TCP for this, or hey, I want to send you some serial strings that do this, They're all kind of saying the same thing. They are technically different. They do mean different things. They're kind of different, but it's just like that nomenclature we're sort of picking up. It's sort of like when you say Kleenex, even though that's like the branded version of it, tissue is the actual word. It's like that. So if I say serial later, if I say MIDI later, or if your console says like MIDI, custom MIDI, or external control, or TCP, we're all kind of talking about this hexadecimal commands. We're writing something and sending it out either over the network or over USB. Okay. Shoo. Already getting into the weeds here. This is good. This is fun. I've learned a lot just making this presentation, guys. So, all right. So the commands themselves, we're writing them in hexadecimal, which I'll get into in just a moment. But just so you know, on the SQ console, it happens over USB and or the network. And there's also actually a place for you to have like a foot switch, like for a piano, where you can program that as well. All the other stuff, the DLive, the Avantis, the AHM, those all happen over the network socket. Okay, so I've said hexadecimal several times now. So hexadecimal is a 16 base number. So a decimal number is how we're used to understanding numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. But once you start getting into double digits, it actually changes how much space or how much data is actually happening. Thus, it takes larger bandwidth. So we've kind of come up with a way, hexadecimal, as a way to express numbers, but then switching to the alphabet. So I have it written there. It actually goes from 1, 2, 3, 4, 5, 6, 7, 8, 9. That all looks normal. And then suddenly we're on A, B, C, D, E, and F. So A actually means 10, B is 11, C is 12, and so on. It's just a way for us to, again, basically have more numbers, larger numbers, without actually taking up any more space. And you'll know this if you look up any of the TCP, IP, or MIDI stuff in any of our documentation or on the knowledge base. We use port 51325 to have all our connections. I'm not even going to get into the port stuff. Just if somebody asks for the port number to get into the Avantis or get into the HM64, that's just the number you need to give them. So if all of your stuff is encrypted, it's 51327. But we won't worry about that right now. This is a mini masterclass. This is not a full-blown college level course. Okay, so let's go over all the different kinds of commands. Basically, what we've programmed into our consoles and into our matrix processes, but what we're able to tell it to do. So the HM, as of yesterday, 2 days ago when I made this, we can change the input level. We can have input mutes. We can have zone levels, zone mutes. We can do control group levels and mutes. We can do preset recalls. We can do crosspoint levels, crosspoint mutes, audio playback, and source selection, all with TCP/IP or MIDI programming. And I might come back and open up. These are all little, let me see if I can do it right from here. Where's my mouse? Nope, can't do it in there. I will copy and paste over it so you guys have these exact documents to let you know. And again, as always, we have great documentation on A&H website. If you guys go there, they have great directions about how to do stuff, and you can check there. And I'll make sure I link those before the end of this. So that was AHM. So the Avantis has fader level, mutes, send levels, DCA assignments, input to main assignments, name and color, scene recalls, MIDI transport, MIDI strips that you can assign that you can actually use to control a DAW. You can also have soft keys and the source selector as well. On DLive, we have fader level, mutes, send levels, DCA assignments, input to main assignments, preamp gain, preamp pad, name and color, scene recall, and MIDI transport. So these are all different things that we can program someplace else. So like just off the cuff, maybe I design an iPad app or something from scratch, not using our very handy custom control. I want to do things the hard way. So I can make that. And so when I push this button, it sends out a hexadecimal command that changes the preamp gain. And I can do that. Or I just want to be able to turn on and off the pad. That's what all of these functions are. And then SQ, which is again is USB or network based, kind of depending on what you need, because it does have that USB-B on the back. There wasn't even a clean list. Like there's so much stuff, and it is such an epic piece of documentation that I just need to let you guys. You just need to go and read it yourself. So even before I go on to the next one, let me paste this over for you guys because it's that important. So SQ for me. Yep. Let's see here. I'm going to copy this, copy link, and then we'll paste it over here for you guys. I'm sure there's an easier way for me to do this, but why would I do that? All right, there's the SQ one. Let's get this DLive one. Copy link. Here's DLive, and all of the URLs are nice and easy to understand, so you know which one you're clicking on. And we'll go up here, copy, Avantis, and the AHM right here. That way you guys have it. There's no excuse. There you go. Okay, back to over here. So we are able to program all these different things. So I'll be showing you guys lots of AHM stuff because that's my bag. It's install and commercial. It is, the install and commercials version kind of a DLive for install purposes. So I'll be showing you through that. I'll also show you some Avantis stuff. But before I walk you into the AHM, I want to explain a couple of terms. So within AHM, we actually have lots of different kinds of external control. We have external control. We also have something called UDP, which is similar to TCP. And then we have TCP, which has been the topic of what I've been discussing so far. If we're talking about external control, where I can type in the hexadecimal command, it's just saying, I'm going to blast this information out onto the network. It's like indiscriminate, like I'm just yelling it out. If it's UDP, it's kind of like saying, I'm going to blast this information out to a specific location, and I'm going to see if it has errors, but I really don't care. And TCP, which is kind of the most ideal and the kind of biggest version, is kind of like saying, I'm going to blast this information out to a very specific location. I'm going to make sure that they got the information okay, and I'm going to check it for errors, and I'm going to fix them. So UDP is like the little kind of younger brother of TCP. We use UDP, for instance, for meter data. If you ever get that set up, the information for that is actually available on the knowledge base, but you can set up UDP to come and get basically meter information. And because we don't have to worry about us getting the information or the packets or anything like that in a specific timeline or in a specific way, we don't have to worry about it. It's kind of a lighter load. The UDP is faster, and you want meter data as fast as possible. But for TCP, we use that for control data because we really need to make sure, did you get this command? Like, did it come up okay? Did you have any errors? Like, is everything good? And if not, please let me fix it. What does the UDP acronym stand for? It's like user-defined programming or something along those lines. You only see it in one specific spot in AHM, but it oddly is not the same. It's user-defined. That's a good question, Donnie. We may have to look that up together. It's user-defined.
It kind of reminds me of DMX. We send a DMX signal out to lights, and we don't care if it works or not.
Yeah. Yes. Yeah. That's a great analogy, and I didn't even think about that. Yes, absolutely, William. It's sort of like, yeah, we're just kind of throwing it out there. We know we're going to check. You got it, and then we don't care from that point. But TCP is this really big, like handshaking. It's a whole interaction of stuff. But Johnny over here was asking, and maybe William, you do know, user datagram protocol. That's what see Colin beat us to it. He went to the Googles and found it. Uh, and then finally, UDP has no acknowledgement of anything actually happening, and TCP does. So if your data is very, very important and you need to make sure that things are coming and going accurately, TCP is what we want to use, which is exactly what we would want. If I'm using a DLive surface and I'm communicating with my mix rack, I would really prefer to make sure that every single thing I'm doing is confirmed and correct. So, all right. Now we can start talking about commands. So here I've got a little, and I'll probably bob back and forth between PowerPoint and System Manager itself. But I've got a couple of command examples for you that we've written. So, and just as a reminder, our Allen Heath gear, we have IP controllers, we have custom control, we can do soft keys, and there's also like a MIDI interface with the consoles. So for an AHM mute on, and if you go to the linked document that I sent just a couple minutes ago, it will list it. And it kind of tells you everything that I believe it's green in the document. Anything that's green is like a variable that we put in. And I've made them red to keep things on brand in this document, in this PowerPoint. But essentially, this is going to be the whole code. So if we want the HM to mute something, when I send this command, it's going to be 9 something, double digits, 7F, 9 something, channel 00. So let's pop out of here. Does CG stand for control group? Yes, it does. Good, excellent point. Yep, control group. That's what this is. Because who wants to write that out? Yeah, zone input or control group. That's for this mute. I can pick whether I want to mute a zone or an input or a control group. On this one, I think I programmed an input. So let's get out of here and let's hop over to this. So this is System Manager. If you guys haven't seen it, it's free to download. You guys could go do this right now and not have to have an AHM next to you. Even though I know you guys all want your own personal AHMs, you don't have to have it. So, all right, I'm going to go over to configure. I'm under controllers, and I just happen to have an IP6 connected, but I could easily just disconnect this and do the exact same thing. So I've just selected a button that I want to do something. It is this one. And on my press function, or I could do on a release. So when I release the button, the command is sent out. I have it set to external control, and you can see all these different options I can actually make this IP6 button do. And let me show it to you guys. Nope, that's that. There we go. That's the IP6 sitting next to me down here. Boop. So I've got it set to external control, and I can click on change external control string and actually type in what I want. And so I'll usually have the document open while I'm programming, because programming with hexadecimal is just like one of those things where you learn it really well while you're trying to do it, and then it decides that it wants to delete itself from your brain until you need it again. And so then you go back, and that's why we have great documentation, because I could not commit this to memory if I wanted to. Rote memorization has never been my strong point. But okay, so I have this control string done, and it's the same one listed here. Let's see if I can that's not what I want. Get that. Scooch this over. I hope you guys can see this okay. I've got like 400 windows open with Zoom. So I've got 9 in, and if you look on that document, I typed 0 because I just wanted it to be like as simple as possible. So it's actually it's an input, which is 0, and then I did the channel number, which is the next after the comma, and it's 00, which means channel 1. And then I typed in what they're telling me to, 7F. Couldn't tell you what that means. Again, that's Allen and Heath's programming, and I'm just instructing it specifically what I want. And then I just repeat the same numbers. Like, yes, it is, 9 in the same number, 9000, and then I end it with 00. Now, I know that I just said a lot of numbers, some letters. It made no sense because we speak English and not computer. But that's why I have these little slides made, just so I can show you guys, like, I'm just typing it. I look at the document, like, hey, I'll even click it open right now. And I'll make a note of what I want to make. Let's see if it wants to open. Maybe I have to do you. Oh, there we go. Oh, there's going to be a lot of things opening now. There we go. Who doesn't want 6 pages of this? Let me take a sip of water while that opens. And also, if you guys are doing this and it gives you a literal headache, that's okay. It happens to me too. I'm trying to do this and I'll have these documents open to make sure I'm doing things correctly, but this is by no means natural. This is not a natural language for us. That's okay. Don't hold yourselves to it. Okay, so I want to hide you guys. Let's see. Hide. All right, then I got the chat one. Okay, so we're looking at this document and it lets you know, hey, these are these functions that you can control. But maybe more to the point is it lets us know, hey, these are what your variables are. So anytime you see something green, that means it's looking for something from us. If it's in black, that just means they're giving it to us. So if I go to channel mute on and off, you can see this is all I need. I'll fill in the green pieces, but I can just copy this and I actually pasted it over. I actually used this PowerPoint to help me. Pasted it over here and formatted it so I could easily read it. And then I went over here and typed it in and made sure I was, going back and forth, like, is this the channel I want? Is this what I want to do? Yes, perfect. And I can hit OK. And so now when I hit this button, it should mute input 1. So I'll even go over to my channels. I'll go make this large. And I'll even switch my camera over, which I think it is now that I've stopped all my camera feeds. Let's see. There we go. I'm going to need, you guys can see this IP6, right? I hid my own camera view and now I've hurt myself in my confusion. Oh, I found it. Got it. Now I don't need you guys. Okay, so now if I hit this button, it should mute it. Ta-da, it does. It's magic, guys. We typed in like 10 digits and now I can do stuff. And so that was a mute on. And I went ahead and looked at the document and I made one that was mute off. And I made this button the mute off. So if I hit that, mute off, mute on, mute off, mute on, mute off. Bueller. So I can do that. And of course it's, we're really going the long way about it because we're able to set up the IP controllers so easily with the normal functions that allows us to do it. But this is just a really good example of maybe this isn't an IP controller that we make. Maybe this is something on your desktop that you wanted to control it with, or maybe this is some third-party piece of like a lighting board that's got some MIDI outputs that you can program and you want to do that. Well, now we can. Now the lighting board will have their own button to mute on and mute off stuff. So then on the next slide, we can also do things like cross-point mute. And this gets a little bit hairier because now it starts using something called a sysx header. And the only thing that you need to know about this is that it's listed in the document and some commands require it. What that actually translates to, couldn't tell you, but that's beside the point. Just know that it'll say sysx header and then it'll just have a little space for it. You'll type it in and then you'll have the rest of the command listed. So this is a little bit more of an advanced piece of programming. So that's why we're using this. It's also the sysx header is just a way that we programmed it to say, hey, when this comes on, like one of these set of items is going to be happening. So I've highlighted it yellow to know that it's listed in the document. You don't need to know it. Just if it asks for it, paste it in. And then so I've also got these listed. So again, the red on my PowerPoint in all of the huge arrows that are pointing to it are what we're going to be filling in. So is this a zone or an input? And then it's 0, 3. And then which channel are you talking about? Which channel of input or zone? And then you're going to list the destination zone or input. So this is a cross-point mute. So we're having an input and it's going to a zone or a bus of some kind. We want to mute that. but we don't want to mute input one itself. So we've got the origination channel, then we've got the destination zone or input. Say, okay, where's it going, and how would you like to would you like to mute it? So we've got that, and we have to list whether it's the destination is a zone or an input, and we have to change the if it's the actual destination channel. So if we pop over here, I have done that because who wants to sit here and watch me do it? It is this bad boy. So I have it on external control, and I can type in my little string here, and I even move stuff over. And so it was, and we'll do it right here. Let's see. You can see which part's the header. It ends in 0100 right here. So if I hit that, there we go. So now I've just added a space so that it's easier for us to read, because again, we're human beings and this is not at all natural. So I've got the little header on the first line, and that is just beyond the scope of what I need to know, other than the system needs it to understand what I'm about to tell it to do. And then we type in what is listed in that sweet, sweet document, where I'm saying, hey, this input to this zone is what I'm telling it to do. And I believe I have programmed this to do input one to zone one, because again, solve the name of simplicity. So if I go back over here and I go to my cross point, I will unmute this. Now, if I hit this button, it should be sending the command to mute input one to auditorium, wireless to auditorium one. Hooray, we've done it, guys. We have done it. We have programmed things with numbers. We're geniuses, and I can just do this all day long. Sweet. And then another one, and I'll go through these quickly. So maybe I want to do a source selection, because that's a very popular, I've dictated a certain, sources are available in a zone. So maybe it's a classroom, and I only want them to be able to switch between like house music and their Blu-ray player or an Apple TV. I only want them to be able to switch between those two things without disrupting the paging mic or anything else I may be sending them. I only want to give them control over two items. That's what we would use a source selector for. And if I pop over here to source selector, I'll go to my zones. I've got two on here. Actually, it's a tunes and it's a phone. And so if I make this, I'll make my second one active. Phone is active, and you can actually kind of see up here on the selector, it has a little white box around the one that I'm actually using, and it lets me know current active source. So I can go down here, and again, I got that sweet system execution header. So I've got that, and then it's just a really simple 1, 2, 3, 4, 5 section kind of hexadecimal command. I just simply tell it 0008, great, and then I just tell it what zone I'm actually referring to and the source number I would like to trigger. So I've done that. If I go over to my configure, I'll click it was this button, and I can have it open this up, and I've got my little 0100, so I can actually put a space there. I usually put an extra space just so I can see the difference. And I've got my command there. So I am simply telling zone one to pick source selection one. Okay, so let's go back over here and let's make sure this actually happened. Visually on my screen right now, you will see this down here change to a 1, and the actual source selection up here move from phone to tunes. And we'll cut back over to my IP controller, and I can hit boop. It did it. It did it. I wish there were explosions also happening, because the satisfaction you get from programming this and then it actually doing it is some kind of weird, like, it's amazing. It just feels like you've conquered, like you can do anything because you are the hardware now. You are commanding it to do things. It's similar when you build something for like GPIO from scratch with like just loose wire, and then you push a button and it does something, which is also communicated over TCP/IP, I may add. It's just very satisfying. So again, this kind of lets us understand how our controllers are actually working with our consoles or with our matrices, but it also gives you an idea of, just because I happen to be using an IP controller to trigger this, I could be using some other piece of gear and trigger something inside of my Avantis or inside of my AHM64. Or the inverse is true also. Maybe I want to use my presets on my HM64 to trigger specific external control. So remember earlier when I had the guy shrugging on the slide and I was like, here's the different kinds of stuff. Here's where you'll see it. So we've got external control, which I'm just vomiting it onto the network, basically. It's just, I'm just spitting it out. So when I recall this preset, I'm vomiting out this command. But then we also have IP control. And we can change between TCP and UDP. So I have this already programmed actually to recall a scene on my Avantis. So this is, I'm programming it on my AHM, but I want to say, hey, when I recall this preset on my HM64, I actually want it to trigger a scene change on my Avantis, which is extremely helpful for things when, maybe you want to switch over the console because there won't be an engineer there, but we need it running, but we need things to be really simple, and it triggers that change for them. So there doesn't need to be somebody coming up and actually doing the scene change, because that's too much for some people, and that's fine. It's all in the name of making things easier and having communication be open in any direction we need. So we can do it that way, or have I could send it to a screen. Maybe a screen motor accepts serial commands or hexadecimal or MIDI or TCP/IP commands, and I want to say, hey, when I do this preset, I want you to send this command out, and that command actually makes the screen drop, or it does a lighting change, or changes the programming. There's just so many things you can do. We're really like just peeping open like what this actually means for us. So we've got the TCP/IP, which again, there's that 41325 if you need it. Remember when I said if it asks for it, you're just going to need to know this number? Here it is. That's all you need to worry about. And you type in the IP address of where you want to send it to. That happens to be the default IP of the Avantis. So, and you can see here, I even made a little note that this actually triggers a TCP command, scene20 recall to a DLive or an Avantis, depending on the IP address you put in, scene20, and it could be the base scene for those consoles. It also happens to do some other stuff. So I can do that easily. I also like to show you, because you guys have already been listening to me for forever, is a little custom MIDI string on my, let me go over here, on my Avantis. So, scoochy scooch. I've got the screen open. It's setup, control, soft keys, and I just have one way down here at the corner, number 23, for custom MIDI. And let me grab my work phone here, because I have took a picture of it. Okay, so it is, and I'll just do the press, and then I get this like funny looking little keyboard. It is actually BB 00 00 CB CB 0F. Apply. Okay, so now if I did this correctly, I go to scenes, and it should trigger a scene change of scene 16. So everybody hold your breath. It did it. Great success. We did it. And again, why would you want to make that 23 specifically just recall scene 16? I'm not going to tell you why you should or should not do that. Maybe you need it, but really just to illustrate, yes, it works on AHM, it works on Avantis. Just because I sent it, I sent out a command that the Avantis understands, so it happened on the Avantis. But I could send that out to some third party, or my DAW, or a motor, or I can go from the IP controller to the Avantis, like all these different ways to program exactly what we want happening between one piece of technology and another. We're able to do that with TCP/IP, MIDI, serial strings, those kinds of things. So now we can open the floor. Does anybody have any questions? Anything you want to see? Anything that wasn't very clear? I know that this was, it wasn't quite the blind leading the blind, but I have not worked for IBM. We'll just say that. But it's, part of my job is helping understand and programming this sometimes. So if you guys do have any questions, please, the floor is open.